Great. Let's move on to the next part, which is proportion. Now, proportion is nothing but equality of two ratios is called a proportion. So we had so far discussed only with A by B, but if A by B is equal to C by D, then A, B, C, D are said to be in proportion. Okay. So for example, 2 by 3 is equal to 4 by 6. Okay. Or 5 by 15 is equal to 1 by 3. Then they are said to be in proportion. And when they are in proportion, it is written like this or like this. So A is to B is equal to C is to D, or A is to B is as C is to D. And then they are said to be in proportion. Here in this case, when you write it like this, it's very obvious. A and D, which lie at the end, they are called the extremes. B and C, which lie in the center, they are called the means. And when you write in a fraction format, it is very clear that you can cross multiply. So A into D will be equal to B into C, or we can also say that product of extremes is equal to product of means. Okay, so this is as simple as the concept of proportion, nothing very complicated. So that's how proportion basically gets defined. Also, A is called the first proportional, B is called the second proportional, C is called the third proportional, D is called the fourth proportional. There is another variation here where we have continued proportion, where it is like A by B is equal to B by C. Okay, for example, 1 by 3 is equal to 3 by 9. Now when both these terms, both the means are same, okay, it will be written like this: A by B is equal to B by C. When both the means are same, then it is called a continued proportion. So where you can see the mean of one is equal to the mean of other, your means are same. So in fact, they are called to be in continued proportion, where B is called now the mean proportional, also the second proportional. A will be the first proportional, B will be the second proportional, C will be the third proportional. So B is the second proportional or mean proportional. And in this case, this will change to B square is equal to AC. Okay. So this also is there, and this is a case for a geometric progression. A geometric progression, always this will happen. 1 by 3 is equal to 3 by 9 is equal to 9 by 27. So when terms are in GP, you will see that first term upon second term will be equal to second upon third, will be equal to third upon fourth, which will be equal to fourth upon fifth. So they are in continued proportion. Okay. So this is about continued proportion. Okay, some more concepts which you should be aware. When four terms are in proportion A, B, C, D, then as I said, A is the first proportional, B second, C third, and D is called the fourth proportional. Also, there are some common derivations which you should be aware. A upon B is equal to C upon D. Now if you divide both sides by 1, okay, you will get B upon A is equal to D upon C. Okay, this is called invertendo because they have been inverted. Okay, so that is the first thing. Then the second case is if I cross multiply one of them, let's say here, so then it will become, what will you get here? Or don't cross multiply this. In fact, I can do two ways. So let's say if I cross multiply this, you'll get A by C is equal to B by D. This will be called an alternando. I can have another alternando if I cross multiply this one. So that will become D by B is equal to, so I have cross multiplied this, is equal to C by A. Okay, so this basically, if you see this one and this one, they're nothing but invertendo of one another. Okay, so this is alternando. Then we have componendo, where what we do is A by B is equal to C by D. I add a plus 1 to both. Then you will get A plus B by B is equal to C plus D by D. This is called componendo. If instead of adding 1 I subtract 1, then this is called dividendo, and this will be A minus B by B is equal to C minus D by D. So this is dividendo. And if I divide my componendo and dividendo, you can see that b and d in the denominator will get divided, and you'll have a plus b upon a minus b is equal to c plus d upon c minus d. This is called componendo dividendo. Useful features, you should be aware of them. One more very useful feature is proportionality of the sum. When four terms are in proportion, then you can add the numerators and you can add the denominators, and they will continue to be in the same proportion. So when I have a by b is equal to c by d, then the same proportion will also be equal to a plus c upon b plus d. And I can have multiple terms, I can add all of them also. And just to understand this, let's say 1 by 3 is equal to 6 by 18. If you add the numerators, 1 plus 6 is equal to 3 plus 18, which is 7 by 21. 7 by 21 you can see continues in the same proportion. Okay, so this is proportionality of the sum. So these are some concepts around proportion. Let's do a couple of questions on these as well. Before that, some more terms. So a list of terms is said to be in continued proportion. We discussed that when successive term is constant. So AB, if A, B, C, D are in continued proportion, then A is to B is equal to B is to C, which is equal to C is to D. This, and in that case, A is called the first proportional, B is called the second mean or middle proportional, C is called the third proportional. Product of means is equal to product of extremes, gives you B square is equal to AC. Also, the ratio of the first and the third proportional is equal to the duplicate ratio. Now, duplicate ratio, if I have A is to B, its duplicate ratio is basically A square is to B square. Its triplicate ratio is A cube is to B cube. Subduplicate ratio is root A is to root B. Subtriplicate ratio is cube root of A is to cube root of B. Just you should be aware of this. So the ratio of the first and the third proportional, which is A by C, is equal to the duplicate ratio of the first and the second proportional, which is A square by B square. These all can be easily derived from your A by B is equal to B by C. Okay, fine. Let's jump into some questions and apply this. So a solution of volume of 40 liters has dye and water in the proportion of 2:3. Okay, so it has dye and water. Total is 40 liters. The ratio is 2:3. So obviously dye will be 2 by 5. Water will be 3 by 5 of 40. So 2 by 5 will give you 16 and this will give you 24. So this is the quantity that will be there. Water is added to the solution to change this proportion to 2:5. So when water is added, obviously dye remains 6. But the proportion becomes 2:5, which means dye should now be 2 by 7 and water should now be 5 by 7. Okay, so 2 more parts of water needs to be added, and here if you see 2:5, basically when the ratio was 2:3, from here itself we can derive each one was 2x and 3x. So basically 5x was equal to 40 or x is equal to 8. This is one part is 8. So basically when 2:3 is being changed to 2:5, you can see that 2 more parts of water needs to be added. So 2 more parts, that means you'll have to add 16 more liters of water. So if you add 16 liters of water, you have 24 already. You add 16 more to this, then you see you have 40 and you have 16. Okay, 16 is to 40, if you check, is 2:5, which is what we wanted. Okay, so now I have 16 and 40, total volume now is 56 liters. Okay, if 1/4 of this diluted solution is taken out, 1/4 is taken out. When you take 1/4, 3/4 will remain, and 3/4 of dye will also remain, 3/4 of water will also remain. So now I have 3/4 of this and 3/4 of this. Okay, so 4 into 3, you have 12 liters of dye and you have 30 liters of water remaining. Okay, then how many liters of dye must be added to the remaining solution to bring the proportion back to 2:3? Okay, so now we have to add dye. So let's say 12 plus x liters of dye I add. So 12 plus x upon 30 should be equal to 2 by 3. So it's very simple. You can see 3 has become 30. So 2 should become 20. To make it 20, x should become 8. Okay. So you'll have to add 8 liters of dye so that it becomes, the numerator becomes 20, and 20 by 30 is equal to 2:3. So the answer would be 8 liters. 8 liters of dye you need to add so that it becomes 2:3. Okay, as simple as that. You just have to go step by step. This is more of a mixtures problem, and I told you ratio proportion goes very, very interchangeably with mixtures and alligations, and you see a lot of questions dealing with mixtures, though mixtures is a separate concept we'll take up later. So let's look at the next question. This I hope is clear. There's no confusion here. So the next question is, the strength of a salt solution is P% if 100 ml of the solution contains P grams of salt. Okay, so this is the information given to us. Now it says, if 3 salt solutions A, B, C are mixed, so let's say A, B and C, and they are mixed in the proportion of 1:2:3. We are not given any value here, so let's assume it is 1 liter, 2 liters and 3 liters. Okay, let these be liters. Then the resulting solution has a strength of 20%. So total volume is 6 liters. 6 liters has a strength of 20%. That means 6 into 20%, 1.2 liters of salt will be there. Okay. If instead the proportion was 3:2:1, so 3 liters, 2 liters and 1 liter, total still remains 6 liters. But now the concentration goes to 30%. That means 1.8 liters. So one thing is very clear, that A has more concentration of salt, B doesn't matter, C has less concentration. So between A and C, you can see that A has more concentration because increasing the quantity of A and reducing C increases the concentration of salt. Okay. In fact, we can see here itself that 1 liter became 3 liters, so 2 more liters and 2 less liters have led to this change. Okay. Then a fourth solution D is produced by mixing B and C. Now we make another solution D, which is by mixing B and C in the ratio of 2:7. So let's say 2 liters and 7 liters. Okay. Then the ratio of the strength of D to that of A is how much? Okay. Let's assume the strength of A is X, strength of B is Y, and strength of C is Z. Okay. Now when I take 1 liter, then you get basically, and X is the percentage value. So let's just keep it like that. So X plus Y is 2 liters. So 2Y, Z is 3 liters. So 3Z. This is the amount of salt that you'll get. Upon 6 is equal to 20% or 0.2, or this we already solved. This is equal to X plus 2Y plus 3Z is equal to 1.2. And the second equation is 3X plus 2Y plus Z is equal to 1.8. If you add all three, you will get basically 4x plus 4y plus 4z is equal to 3, or x plus y plus z is equal to 3 by 4, which is 0.75, though this is not very useful for us here. So rather than this, we would be subtracting both. So let's subtract both. You will get 2x minus 2z is equal to 0.6, or x minus z is equal to 0.3. So X, or solution A, has 30% more concentration than C. Okay, fine. So now the question is, a fourth solution D is produced by mixing B and C in the ratio of 2:7. So 2 liters will give you B and C is 2:7. That means 2y plus 7z upon 9. This is going to be the concentration in D. And to that of A, the concentration of A is X. So this is the question. 2y plus 7z upon 9x is what we have to find out. So we will not get all the values clearly, okay, but we don't need all the values also. Basically, we want to express y and z in terms of x. We want to express everything in one. So let's look at the first one. From the first one, in fact, when we have solved both the equations, x minus z is equal to 0.3, or z, from here I can say that z is equal to x minus 0.3. So z is already in terms of x. If I replace this in any of the equations, so let's replace in the second one because z is there with no number getting multiplied. So 3x plus 2y plus z, which is x minus 0.3, is equal to 1.8. 3x plus x, 4x. 4x plus 2y is equal to 2.1, or y is equal to 2.1 minus 4x by 2. Okay, or it is equal to 1.05x minus y is 1.05 minus 2x. So I have y also, I have z also. So let's put that in this equation. So my resultant concentration is 2 into y. In fact, it was 2y, so we could have kept 2y itself, which is 2.1. So let's keep 2y. 2.1 minus 4x plus 7z, 7 into x minus 0.3 upon 9x. So this, if you see, is 2.1 minus 4x plus 7x minus 2.1 upon 9x. 2.1, 2.1 gets cancelled. You have 7x minus 4x, which is 3x by 9x, which is 1 by 3. So your answer is going to be 1 by 3. So the ratio is 1:3. So this again is more of a mixtures and allegations question. And if we want to just apply the concept of proportion and ratio, this is how this can be done. Okay, let's move on. Total salary of ABC is rupees 35,000. They spent, okay, so A, B, C. We don't know the actual salaries. Let's say it is A, B, and C. They spend 75% than their respective savings. Okay, they spend 75%, 80%, 56%. So they save how much? 25%, 20%, and 44%. Of what? Of the salary. So the amount saved will be 0.25A, 0.2B, and 0.44C. And it says the savings are in this ratio. So let's look at A and B, for example. A and B is 0.25A upon 0.2B. This is equal to 10 by 12 or 5 by 6. Okay, and this also is 4 by 5. Okay, so 6 into 5, 30A is equal to 20B, or A by B is equal to 2 by 3. Okay, similarly, let's look at B and C. So savings and B and C is 0.2B upon 0.44C, which is equal to, from here, 12:33. Okay, so then simplifying this, dividing by let's say 4, so this becomes 20 by 44, which becomes 5 by 11. This becomes 3. So 5 into 3, 15B is equal to 12C, or B by C is equal to 12 by 15, which is 4 by 5. Okay, so I have A is to B, 2 is to 3, and I have B is to C, is 4 is to 5. I have to combine them. So let's multiply this by 4, let's multiply this by 3. So A is to B is to C is 8 is to 12 is to 15. 8 plus 12 plus 15 adds to 35, and the amount is 35,000. So the common constant is 1,000. Okay, so obviously the salary of A is 8,000, the salary of B is 12,000, and the salary of C is 15,000. So my answer, what is the salary of C? My answer is going to be 15,000. So simple question where we have different ratios and we have combined those ratios using the concept that we had discussed earlier, where the common term is made same, and then we can easily combine them. Okay. This question again is a CAT question. A upon B plus C is equal to B upon C plus A is equal to C upon A plus B, which is equal to R. Then R cannot take any value except. Okay. One very simple method to solve this is obviously by putting values. You can see all your answers are 1.5, plus, minus, whatever. So one simple thing would be that I put A is equal to B is equal to C, which is equal to 1. Put it equal to 1. You will see that all your equations will change to half. Okay, so obviously R is equal to half is possible. When R is equal to half is possible, then this answer is ruled out. This answer is ruled out. The answer is either first or third. Third, there is a -1 also. Okay, third, there is a -1 also. Fair enough. Then let's try some other value. And a lot of these questions actually can be solved by just putting some values. Because there's a negative value, I just have to check for -1. I'll have to put some value as -1. Okay, not -1, a negative value, but I can't put -1 because if you do a -1 and a +1, then in some case the denominator will become 0 and denominator cannot be 0. So instead, let's do one thing. Let's do -2, 1 and 1. Let's put one value, any value, A as -2, B as 1, C as 1. Then if you see, the first one will become -2 by 2, which is equal to, second one is 1 upon +1 minus 2, which is equal to 1 upon -2 plus 1. So this is -1 is equal to -1, which is equal to -1. So you get -1 also. Hence your answer is choice 3. Very simple. Just by putting couple of values, you will get the answer. Okay. Otherwise, of course, there is a long method also where I can solve them. One thing is that if you remember the summation of proportions, so add all the numerators. So this whole thing is going to be equal to A plus B plus C upon 2 times A plus B plus C, which is equal to half. So half you will get like this also. Okay. And then for -1, we can do cross multiplication. Okay. If you cross multiply first and the second one, you will get AC plus A square is equal to B square plus BC. And similarly, you solve other ones, and then you'll get a relation which will give you R is equal to -1. Okay, but not required. Wherever we can substitute values, nothing better than that, substituting values and getting answers straight away. Okay, great. Let's move on to the last part, which is your variation. Okay, So variation again is a part of proportion, but where we have quantities which vary with respect to the other. And there are two broad types of variation. One is a direct variation and second is an inverse variation. Direct variation is when both move in the same direction. For example, distance and speed. Distance is directly proportional to speed. When you increase speed, and assuming your time is constant, and assuming that your time taken is constant, when you increase your speed, your distance will increase. When you decrease your speed, your distance will decrease. So both of them increase. If this speed increases, distance increases. If speed decreases, distance decreases. So it's a direct variation. Second is an inverse variation, which is speed is proportional to this time when distance is constant. This I'm sure. When distance is, let's say 100 kilometers, you go at a speed of 50 kilometers, you will take 2 hours. If you go at a 25 kilometers, you will take 4 hours. So if you reduce your speed, you will take more time. You increase your speed, you will take less time. So that is the inverse variation. Okay. Also in direct and inverse, there are some other examples where if A increases, B increases, but not in the same ratio. Here, if you see, it's the same ratio. If my speed doubles, my distance will also double. If my speed becomes half, my distance will also become half. Here, if my speed doubles, my time taken becomes half. If my speed becomes half, my time taken will become 2 times. So they are changing in the same proportion. But also there are direct and inverse variations where though they move in the same direction or opposite directions, they do not move in the same proportion. For example, let's say you have a telephone connection at home and that telephone connection gives you 200 free calls. So you pay a monthly rent of 200 rupees. Okay. And you get 200 free calls. Okay. So now if you see your calls and your bill, they are in direct proportion. But if you make 100 calls, your bill will be 200. If you make 200 calls, your bill still is 200. If you make 300 calls, and let's say the rate per call is 2 rupees. Okay, so till 200 these were free calls, there is no charge. Now you have made 300, so you have made 100 extra calls. For that 100 you will pay 200. So now your bill will be 400. You make 400 calls, you will pay for the 200 extra calls. You are going to pay 400 rupees plus 400 rupees. You are going to pay 600 rupees. Okay, so you can see that here your bill is constant. Now here from 200 to 400, your number of calls have doubled. Okay, but your bill has become 3 times. From here to here, 300 to 400, your calls have increased 1/3, but the bill has increased half. So this is where they do move in the same direction, but not in the same ratio, or not in the same proportion. That also is a type of direct and inverse variation. Okay, then there are 2 more types where we have more than 2 quantities. So this direct and inverse, we dealt only with 2 quantities, distance and speed, let's say, or speed and time. What if you have more than 2 quantities? Then we have joint and combined variation. Joint variation is where you have more than 2 quantities, so 3 or more quantities, but they again move in the same direction. For example, distance is equal to speed into time. So distance, if you see, moves or varies directly as the product of 2 variables, product of speed and time. Okay, still it's a direct variation, but it is the product of 2 direct variations. And second is a combined variation where some variables vary directly and some vary inversely. For example, this you might have studied in school. Force is directly proportional to mass upon distance square. So force varies directly with mass but inversely with distance. So this is a combined variation. Okay, so for 2 variables we have direct and inverse. For more than 2 we have joint and combined. Okay, let's do a couple of questions, not very complicated. So let's say we have this question. The cost of diamond varies directly as the square of its weight. So cost varies directly as weight square or cost is equal to kW square. Okay. Once this diamond broke into 4 pieces with weights in the ratio 1:2:3:4, that means the weights are 1x, 2x, 3x, 4x, and total there is no weight loss. So before breaking, the weight must have been 1 plus 2 plus 3 plus 4, it must have been 10x. So this is the original weight. Okay, this is the broken weight. Okay, so this is the weight. So what is the cost? The cost obviously would be k into 1x square, k into 2x square, k into 3x square, and k into 4x square. And original cost would have been k into 10x square. Okay, and says the merchant got 70,000 less, which means the original cost k into 10x square minus the weight of each broken piece 1x square plus 2x square plus 3x square plus 4x square is equal to 70,000. That's my data. Okay, so 10x square is how much? 100 kx square minus, now this is 1, this is 4, this is 9, and this is 16. If you add, it comes to 30. So you'll get 30 kx square is equal to 70,000. 100 minus 30, 70. 70 kx square is equal to 70,000. And all the constants can be combined. So kx square is equal to 1000. Okay, find the original price of the diamond. So original price was this, which is 100 kx square. 100 kx square. Kx square is equal to 1000. So it is 100 into 1000, which is 1 lakh. Okay, so original price was 1 lakh. What he got of the pieces was 30,000. 30 kx square will be 30,000. So he got 30,000, and hence that is the loss. Why did the loss happen when the weight did not change? The loss happened because the cost was proportional to square of the weight. Okay, and 1 plus 1 square plus 2 square plus 3 square plus 4 square is much lower than 10 square. Okay, so that is the logic. So that's how this can be done. Let's look at one more. Arvind Singh purchased a 40-seater bus. He started his service on route number 2 from Mahunaka to Devas Naka with a route length of 50 kilometers. His profit from the bus depends upon the number of passengers over a certain minimum number of passengers and upon the distance traveled. So you can see that this is a direct variation, but it is a delayed directory because first he needs to have a certain number of passengers where he'll break even, and then he will make profit. Okay, and upon the distance traveled by the bus. So let's say upon a certain number of passengers n. So here your equation will be that we have the distance traveled, his profit. So profit is equal to over a certain number of passengers. Okay, so first case profit is 3600 when 29 passengers are there and 36 kilometers. And second case profit is 6300 when there are 36 passengers and the distance covered is 42 kilometers. So you can see it is increasing with passengers and distance, but not in the same ratio. Okay, so my equation here will be that my profit is equal to, what do I do? My passengers minus a fixed number of passengers into distance. Okay, into some constant. So it is proportional to this. Okay, because it says his profit depends upon the passengers over a certain minimum number of passengers and upon the distance. So I'll make the equation as P is equal to K into passengers minus minimum number of passengers into distance. Okay, So my first data is 3600 is equal to K into 29 minus n passengers into 36 kilometers, and second case 6300 is equal to K into 36 minus n into 42 kilometers. Okay, to solve first, let's divide them so that K can get cancelled, and 36 and 63, both of them are multiple of 20, both of them are multiples of 300, so this will become 300, so 12 upon 21, which can further be reduced, but we'll do that, is equal to 29 minus n into 36 upon 36 minus n into 42. So this is 2 times, this is 3 times, so 2 into 36 minus n, that means 72 minus 2n is equal to 87 minus 3n, or n is equal to 15. You get n is equal to 15. So the first question, the question is that itself, what is the minimum number of passengers required so that he'll not suffer any loss? It is 15. He needs 15 passengers. If you also want to know that what is the constant, that also we can find out, but that does not help. 15 is the answer for this question. Okay, so that's how these questions get solved. Thank you so much for attending the class, and as I told you, it's a chapter that gives you some number of questions definitely in every exam, and you also have these concepts applied in your averages, mixtures, alligations, speed, time, distances, so many other concepts. So you have to be really strong here and make sure that you do not miss out. In fact, last CAT I showed you, we had a DI set of 5 questions based on this. Okay, so you can't miss out on that. So do practice this well, and all the best for your preparation. Thank you so much. Take care. Bye-bye.